Hello. So in this video we'll continue our discussion about Hamilton paths and circuits, and specifically we will prove a theorem which is the so what is the definition? As we saw in our introduction of Hamilton paths and circuits, if G is a simple graph with n vertices and n is greater than 2 such that the degree of u plus degree of v is always at least equal to n for each non-adjacent pair of vertices u and v, then G has a Hamilton circuit. Okay, so a strategy to prove this is what? Is by contradiction. Okay, so we will say that let G satisfies the condition. And condition is what? Condition is this guy. But is not Hamiltonian. Again, Hamilton and Hamiltonian are the same. Okay. So this is our starting point. Okay. Now we have to do some activity here. So we'll say form a graph G star from G by uh, adding edges form G star from G by adding edges we get until we get a non-Hamiltonian maximal graph. So this means what is a maximal? It should be maximal non-Hamiltonian graph. It means that if we adding only one edge should make it Hamiltonian. Okay, so we are doing it. Okay, so this means that if it does not have a Hamiltonian circuit, it should have a Hamiltonian path, because adding one edge with should make it Hamiltonian. So this means that a Hamiltonian path exists. Correct? Let's say Hamiltonian path exists like this. U is the starting vertex. Then we have intermediate vertices. Uh, and then V. And V is our final vertices. Okay. Now note that if I just add the vertex, so I just say UV, adding UV will make it Hamiltonian. So this means this path exists U to V through x1 to x minus 2, and if I just add one more vertex UV, then it will make it Hamiltonian. Okay, now we just try to make a observation here. So we'll say that if node xi or vertex xi is adjacent to u, then xi minus 1 cannot be adjacent to v. Okay, why? Now let's say that if this is false, that xi is adjacent to u and xi minus 1 is adjacent to v, then what happens? What happens is that we can start with u. We can say u x1, x2 up to xi minus 1, and then v, and then this path says that n minus 2 is also adjacent, so x n minus 3 up to xi, and xi is adjacent to u. So this means if this was false, then this would be a Hamiltonian circuit or Hamilton circuit. So this means this is true. So I'll say just this is just otherwise or else. Okay. Okay. Now what does this statement mean? This statement means that the degree of V, which is obviously less than n minus 1 because there are n vertices, okay, and it's a simple graph, so without any loops, but it has another constraint that it cannot have this many of more nodes, because how many xi's are possibly adjacent to u? Degree of u. So then this means if I just play with this, I can say degree of v is less than plus degree of u is less than n minus 1. But we said that degree of u plus degree of v is greater than or equal to n for each non-adjacent pair, and u and v obviously are non-adjacent. Okay, so this means it's a contradiction. Okay, since it's a contradiction, then Or's theorem is proved. Okay, proof. Hope it was easy to understand, and thanks for watching. Hope you liked the video.